So, let's look at applying Coulomb's law. You know the equation for Coulomb's law is F equals K Q1 Q2 over R squared. Don't forget the squared. Square gets very lonely. Calculate the electrostatic force that two charges plus 3 microcoulombs and minus 8 microcoulombs exerts on each other when they are a distance of 30 millimeters apart. So we want F. We know that Q1 is plus 3 microcoulombs. We can't work with it in microcoulombs. That's 3 times 10 to the minus 6 coulombs. Q2 is minus 8 microcoulombs. So that's minus 8 times 10 to the minus 6. I'm only going to consider those signs when I have to do direction at the end. 30 millimeters for the distance, got to be in meters, so I'm going to divide by 1,000, 0,03 meters. F equals K Q1 Q2 over R squared. So we have 9 times 10 to the 9, 3 times 10 to the minus 6, no negative there, we leave it as it is, 8 times 10 to the minus 6, and we're all going to divide that by 0,03 squared. So we take out our calculators. Very important, we put it in our calculator and we get an answer of 240 newtons. I'm saying that it's attraction, that's its direction, because I have a positive charge and a negative charge, and unlike charges attract. I can't say left or right, because if my one charge is here, the other charge is here, the one's going to go to the right, the other's going to go to the left, so left or right doesn't make any sense when I just want the force between them. But they are attracted to each other, so we're going to call that attraction. How will this force be affected if the distance between them is halved? How will the force be affected? They're not asking what the force becomes. By asking about how the force will be affected, they're going, will it be 2 times bigger, 3 times bigger, 4 times smaller, 9 times smaller, 306, whatever. They're looking for the factor. This is a ratio question, so we need to find something we know. The original force was KQ1 Q2 over R squared. For my new force, I've halved the distance. 0.5 squared is 0.25. Okay? 1 divided by 0.25 is 4. That's 4F, but how did I get 4F? Because I need to remember that the original KQ 1Q2 over R squared was the F. We're looking for something we know. We're comparing it to something we know. They did not want to know what the new force is. You are obviously welcome to work out the new force and then work out by what factor it changed, but you're doing a lot of work for very, very few marks, okay? So what you're going to do now, and that's the answer, will be 4 times bigger, is now you need to go to activity 1, page 209, and do questions 4 and 5. Once you've done that, you can go on to the next video for doing net force.